Hey guys, Chavez here. Let's get ready to go right into, I guess the topic is 2.4 compound interest. That's what they have in the Decathlon little table of contents. So I just put together here a few questions. These are pretty straightforward, guys. This is gonna be in four parts. We're gonna just work on one part specifically, and then we'll go to the next one, and so on and so forth. And I consider this more of an overview than notes. But you can call them notes, I guess, if you want. I think you cover this in algebra two, maybe even algebra one, when you're doing exponential functions. And Specifically, we're going to be talking about money, right? Like how much money you have in your account after so many years. So we'll be using this formula and this formula, but this formula really is pretty much the same as this one. Let's chat about specifics of more or less where this come from. So money grows exponentially, just like bacteria in a petri dish. And I guess you can say bacteria in a petri dish. Maybe it's a logistic growth because eventually, you oversaturate. But money doesn't work that way. And in case you're wondering, what is this R over N? That one is like 100%, and that one R over N is like adding a percentage. So let me give you like an example, not directly related to this, but just so you guys can understand. So let's say you buy something that's $100 here, and right now in San Antonio, the tax rate is I can't even spell today. Antonio. The tax rate is 8.25%. So let's say you buy something that's $100. How much would it be total, including taxes? Well, if it's $100, the tax is going to be $8.25. So how would you force that in a calculator? You would go 100%, which is one plus, and then this in percentage is point. Let's see, 22. So 0.0825%. So you go plus 0.0825%, and that is 1.0825. And if I take that $100 and I multiply by that, you will get 108.25. So, and that's obviously the price, right? And sure enough, if I take my calculator, and this is going to be heavily calculator dependent, if you go 100 times 1.0825, look, you'll get that 108.25. So that's not directly related, guys. I just wanted to show you where this R over N comes from. What does it stand for, right? So A stands for amount, and then the stands for interest rate, and then the N stands for how often it's compounded. How often it's compounded. The more you compound it, the more money technically you'll have, right? And with reference to the year, right? With reference to a year. And then the T is, because we're talking about money, the T is going to be in years. But this actually depends, because this is an exponential function. It could actually be in reference to a decade, in reference to an hour, in reference to, if you've done half lives or double lives. It just depends, right? But when we're talking about money, it's usually going to be in years. So I'm going to say, when chatting about money, comma, T is in years. And we'll do problems later on where they're not in reference to a T, when it's not in reference to a year. Sorry about that, guys. If you read a different textbook, they might say something different. It just depends. It just depends on the reference. So just keep a note of that. And what can N be? Well, how often it's compounded. So how often are you compounded? If it says the word quarterly, that means that N is 3. So you know what? N is 4, sorry. So let me go ahead if N equals 4, that means compounded quarterly. Because you got 12 months in a year, and if it's compounded quarterly, that means every 3 months it's a quarter. That's what it means. Compounded quarterly in a year, that means you got 4 quarters. That completes your whole cycle. 4 quarters completes your whole year. If it's compounded monthly, and I guess maybe I should have written this like that. That means that N equals 12, because there's 12 months in a year. If it's compounded daily, that means that N equals 365 days in a year, because that's how many days there are in a year. I know, 366 on every 4 years, right? But we're just talking about a regular year here, unless noted otherwise. But it's always going to be regular year. Let's see what else. It could say compounded biannually. Biannually. So that means that n equals 2, because biannually means every like half the year, every 6 months, and then compounded annually. Compounded annually means that n equals 1. And I think I got them all except for this one right here. That east, that when you use that one, okay, I'm going to change the color on here, guys. We use a equals PE to the rate times tie when n when compounded continuously. When compounded continuously. And technically that means that n is infinity. And I don't want you guys to be a robot. Let me show you where this comes from. This is we're going real fast here. I know, but it's because this is not necessarily very technical. It's pretty easy. You just kind of plug and chug. But to make a long story short, if I told you 1 r to the n raised to the nt, this is similar to like 1 plus 1 over x parenthesis to the x. Because remember, we're saying that n approaches infinity. So that's like holding r constant, because if n approaches infinity, this fraction here, r over n is going to be approaching 0. And then you got some number huge times t. So then this approaches infinity. And I know that maybe you know enough that you're like, that's indeterminate form. You need some calculus. Bear with me here, guys. So I'm just going to hold r constant. So I'm just going to put a 1 there. And I wrote x there. I should have written x. I wrote n there. I should have written x. So there it is. So this is similar to this. Now I want you guys to see what happens to this expression right here as x approaches infinity. And in calculus, you would write limit as x approaches infinity of 1 plus 1 over x all raised to the x. And this equals something very specific. So I'm going to take out my calculator. And I know, guys, we're going pretty fast here. If you don't have this background, this might not make sense, and it's okay. Just fast forward. All you got to know is how to use it. But I don't want you to be a robot. I want you to see where this formula comes from. So I'm going to type in 1 plus fraction 1 over x. I'm going to close this sucker, and I'm going to put raised to the power x. And what I'm going to do is I'm going to change my table set, and I'm going to put ask. And now, when I go to table, I can just ask. I can type in numbers. So here's what my output is coming out every time I'm putting these numbers. Every time I put an x value. I want you to see, it looks like it's capped out, but it actually keeps going forever. Notice that the number changes. But I want you guys to notice that 2.7182, it's converging on a number. What number is it converging? A lot of people call this Euler's constant. Not to be confused, if you Google it to Euler Mascheroni, and I actually think I'm saying Euler wrong. I think it's you say it Euler, but I've never gotten that habit out of me. Anyways, look, I can remember that number that we got, 2.7182. So it looks like it's converging at that number. And check it out. If I put E, 2.7182, so it converges, and it converges to the letter E. So that's why that's what we call this. And that's Euler's constant, by the way. That's what we call this E. And you can just replace the 1 plus 1e 1 over x raised to the power x. You can just replace that with x. And that's why this formula goes from P 1 plus r over n to the nt to PE raised to the RT. If that didn't make sense, guys, don't worry. You'll be fine. If you guys feel like your parents should watch some of this, because it's pretty good stuff, or, whatever, let's just get right into it, and let's see if you guys get it. It's pretty simple, guys. It's not even that bad. You're just pretty much we're going to keep the questions pretty simple. You're not going to make monthly deposits, because then it becomes kind of like a series. So all right, here we go. Roe invested $800 in an account, paying an interest rate of 3.5%. So your rate is 3.5%, but in decimal, that is 0.035. Compounded quarterly, so that means that your n equals 4, because if it's compounded quarterly, that means 4 times in a year. Assuming no deposits or withdrawal are made, because then that creates a different type of problem here. How much money to the nearest cent would be in the account after 8 years? So t equals 8 years. All right, the initial amount invested is 800, so we're going to say that's your principal. Sometimes they say A naught, 800. Sometimes they call this A with a little naught. That just means initial amount. Just means initial amount. If you've done physics or if you've done advanced mathematics, you probably already know that. Yeah, I think we're good, guys. So we're going to be using this formula. We're going to say the amount equals principal, parenthesis 1 plus r over n raised to the nt. So let's see, the amount that we're going to have is going to equal to 800, parenthesis 1 plus, the rate is 0.035, so 0.035, and it's compounded quarterly, so we're going to divide that rate by 4 times. And let's see, raised to the nt, so 4 times 8. And there it is. So that's what we're going to type this into calculator. Type into calculator. And it says to the nearest cent, so hopefully we get this answer right here. So 1,057.22. Let's see. So let me take the calculator out. And we're going to go 800, parenthesis 1 plus, and then alpha y equals to get the little fraction. Unless you have the advanced calculator, you can just push alpha that. And then on the top, I already forgot the percentage. Let's see, what was it? 0.035. So 0.035, and it's going to be 4 times. Close it, parenthesis, raised to the power 4 times 8. Yeah, you can just type in 32 there, right? And there it is, guys, 1,057.22, because you're going to round that 5, not truncate it. Because of that 5, you're going to round that 1 to a 2. So 1,057.22. So let me go ahead and put that in here. A equals 1,057.22. Dollar symbol. And yep, we got it right, guys. Good job. All right, guys, let's go ahead and go to the other one. See, it's not so bad. Probably by the time you do 2 or 3 examples, you probably are like, okay, I got it. But bear with me. I would, try to go through all of them here. Vega invested $240 in an account, paying an interest rate of 2.3 compounded annually. So already compounded annually, so n equals 1. This is your principal amount. Assuming no deposits or withdrawal are made, how much money to the nearest dollar, guys, would be in the account after 9 years? So T equals 9. All right, so here we go, guys. Amount equals, you put in $240, parenthesis 1 plus, your rate is 2.3%, so that means 0.023. If you move the decimal 2 times to the left, so 0.023 divided by 1, so I guess that's just 0.023. You should just leave it like that. And then 1 times 9, so it's going to be 9. So just type this into the calculator. You don't need to divide by 1. Anything divided by 1 is itself. So 1 plus 0.023, you can just type 1.023. And there it is. So 240, and let's see what this gives us. 240, parenthesis 1.023. Hopefully I didn't do a mistake. Raised to the power 9. 294.50. Now, because it says 5, so we're going to round this up to 295. So amount 295, because they wanted a dollar amount, guys. It's set to the nearest dollar. And there it is. Sorry about that, a happy face. Let's keep going. Now we got De Leon doing something here. De Leon invested $1,100 in an account, paying an interest rate of 3.8%. Not bad. That's pretty good. Compounded daily. Ooh, daily. So that means N equals 365 relative to the year, right? Let's see. This is my interest rate. So R equals 0.038. Assuming no deposit or withdrawal, how much money to the nearest cent would be in the account after 10 years? So T equals 10 years, guys. And again, this is becoming copy-paste, right? It's pretty straightforward. So the amount is going to equal, let's see, the initial amount is 1,100, parenthesis 1 plus 0.038, and it's compounded daily, so 365, and then raised to the power, the N is 365, and the time is 10 years. So there it is. We're going to type that in. It says to the nearest cent. So let's see what we get. 1,100.038, and let's see if I can remember all that. So 1,100, parenthesis 1 plus alpha y equals, enter, and 0.038 divided by 365, close it, and raise to the power 365 times 10. Let's see. Yep, we got it, guys. 1,608 with 48 cents. Excuse me. 1,608 with 48 cents. There it is, guys. All right, let's keep going, guys. All right, now we got Peanut here. Peanut invested 160 in an account paying an interest rate of 5.7%. So here's the initial amount. Here's your rate, 0.057, compounded continuously. So make sure you underline that word continuously. Assuming no deposits or withdrawals made, how much money to the nearest $10 would be in the account after 17 years? If it's compounded continuously, guys, we're going to be using this formula right here, compounded continuously. See? Compounded continuously. So here we go. You're going to say amount equals principal, which is $160, rate e to the rate times time, 0.057 times 17. So here we go. We're going to take our calculators, and that's what we're going to type in. 160, and then the e is right here. You see that it says e to the x? I guess you could also use this one up here, but use this one, guys. So we're going to go second e to the x, and we're going to type in, and I already forgot the rate, 0.057. So 0.057 times 17 years, 421.65. Did they want nearest dollar or nearest $10? So nearest $10, so we're going to say 420. 420, because it's to the nearest $10, guys. And sure enough, we got it, guys. Yay. All right, one last one, guys. I hope I'm saying this correct. Yushnitzz, if I'm not saying it correct, let me know, please. So Mr. Yushnitzz invested $690 in an account paying an interest rate of 5.6%, compounded monthly. Assuming no deposits or withdrawals are made, how much money to the nearest $10 would be in the account after 8 years? Again, to the nearest $10, guys. So this is the initial amount, and it's compounded monthly, so that means n equals 12, because there's 12 months in a year. And here we go, guys. Amount equals, so 690, parenthesis 1 plus the rate was 5.6%. So get rid of that percentage symbol in the end. So move the decimal 2 times to the left. So 0.056. So 0.056 divided by 12, because it's compounded 12 times. Raised to the power 12 times 8. And I put n instead of 12. 12 times 8. All right, so there we go. And let's do that. So let's see, 690, parenthesis 1 plus alpha y equals, and 0.056 divided by 12, 0.056 divided by 12, raised to the power, and we said 12 times, I already forgot the years, guys, short-term memory here, 12 times 8. 12 times 8, and notice I didn't put it as an exponential. Tisk. 12 times 8. There we go. 1,078, but they wanted us to round it to the nearest $10, so 1,080. So 1,080. All right, let's see if we got it right. Yep, we did. All right, guys. I hope you guys enjoyed it. Hook me up with a thumbs up if you feel like it. I guess you could give it a thumbs down too, but go ahead and give it a shot. See if you can do some of these questions. And I'll probably post part 2 of 4 later on tonight or maybe tomorrow morning. Depends on what time I come back. But yeah, take care of it, guys. And that'll be it. Let me know if you have any questions. All right, later. Bye.